Dear students, now let us talk about the position isomerism. So this type of isomerism will arise due to difference in the position of same functional group on the carbon chain. It means that in both the isomers there will be same functional group. But the position of functional group will be different on the carbon chain. Now the arrangement of carbon atoms will remain same, just the position of functional group will vary. For example, here we have the first example of chloro propane. Now chloropropane means propane has a chloro group attached to it. It will be like this. This will be 1 chloropropane. In the same way, we have another chloropropane in which the position of chloro group will be different. It will be attached here. Please keep in mind the 4 bonds and 4 valencies of carbon atoms. Now this will be 2 chloro as it is on carbon number 2. So it will be 2 chloropropane. So you can see that just the position of the functional group which is attached to the carbon chain is changed. So this will be 1 chloropropane and this will be 2 chloropropane. The next example is of butene. Butene means it will have a double bond, carbon-carbon double bond, and these are alkenes. Now we have studied that double bond is also included in the functional group. So the butene will have 2 positional isomers depending upon the position of this double bond. Let us draw. Now this is 1 butene, as on carbon number 1 we have double bond, so this will be 1 butene. On the other hand, we have now here the double bond is shifted between 2 and 3 carbon, so it will be 2 butene. The double bond is between carbon number 2 and carbon number 3, so it will be 2 butene. Now the third type of isomerism is the structural isomerism is functional group isomerism. Now here there will be different functional groups. But despite of different functional groups, the molecular formula remains same. So then they will be said to have or exhibit the functional group isomerism. For example, there are 2 compounds having same molecular formula, which is C2H6O. So this is the molecular formula. When they are drawn in 2 different ways, it can be either this is ether. So this is dimethyl, 2 methyl groups, dimethyl ether. Ether is just this O group attached to 2 different alkyl groups. Now we have ethyl alcohol. Ethyl alcohol. You can count the number of carbon atoms, hydrogen atoms and oxygen atoms. This is same in both of the compounds, but here the alcohol group is attached and here we have the ether group. The functional groups are different, but despite of the difference in the functional groups, the molecular formula they will remain the same. They will not change. Now let us discuss the fourth type, metamerism.